Hello, this is Ankit Reddy. Welcome to the .NET course from educators.com, world's best online training tutorial for the leading technologies. Today, let's discuss about the types of variables. Those are called value types, reference types, and the stack memory and heap memory. Basically, in .NET, the types are broadly categorized as value types or reference types, meaning that the types in .NET framework are either created at types in .NET framework are either treated by value type or reference type. So a value type holds the data within its own memory allocation. Here, a value type holds the data within its own memory location. And a reference type contains pointer to another memory location. That holds the real data actually. Okay. So reference type variables are stored in the heap, while value type variables are stored in the stack. Just remember that value types are stored in the stack memory, whereas reference types are stored in the heap memory. A value type stores its contents in memory allocated on the stack. When we created a value type, a single space in memory is allocated to store the value. Let me tell again. A value type stores its contents in memory allocated on the stack. Let me show you the pictorial format. This one. Stack. Value types will be there here, and heap contains reference types. Again, for the heap, reference will be there in the stack memory only. Actual value will be here, but address will be there in the stack memory. So a value type stores its contents in memory allocated in the stack. When you created a value type, a single space in memory is allocated to store the value here, and that variable directly holds a value. If you assign it to another variable, the value is copied directly and both variables work independently. Suppose int I is equal to 10, we have declared. After that, int j is equals to I. This means, let me repeat again. If you assign it to another variable, before that we have created a value. We have stored a value into one variable. After that, we are assigning it to the another variable. I is a one variable. It holds 10 value, and we are assigning I to another variable. So the value is copied directly and both variables work independently. The examples are for value types are integer, character, and we discussed this in the previous sessions also. Float, double, whatever it is, the values which you contain. Decimal. These are the examples we can tell for value type. These will be sitting under stack memory. And let me tell one more thing. Value types can be treated at compile time. Value type can be treated at compile time, and as it is stored in stack memory, because of storing this in a stack memory, garbage collector can't access this stack. We have two things called compile time and runtime. Compile time in the sense at the time of your coding your program or typing your program. That time is called compile time, and also called when you build your application that will compile entire code. That is called a compile time. And runtime in the sense after compilation only runtime will come into picture. Runtime in the sense when you are executing your application. That is called runtime. Please remember these two words. It will be most of the times we'll be using in the coming classes. Compile time and runtime. Value types can be treated at compile time and stored in the stack memory. Because of this, garbage collector cannot access this stack. So this is the last point I want to tell. The value type. Just remember that value types stores the value directly, and these are stored in the stack memory. 2 points and examples: integer, character, float, double, decimal. These 3 points please remember. Value types holds the data within its own memory allocation, and value types are stored in the stack memory. Coming to this reference type. Reference types are used by a reference which holds a reference to the object but not the object itself. Let me type this reference type again. Reference types are used by a reference which holds a reference. That means address. Usually people will call address also, or some people will call reference to the object, but not the object itself. We have seen in the picture. Pointer to the reference type but not the object itself, but the value will be here. Address will be in the stack memory, value will be in the heap memory for the reference types. So because reference types represent the address of the variable rather than the data itself, assigning a reference variable to another doesn't copy the data. This means that when a reference types variable is no longer used, it can be marked for garbage collection. Here I told that garbage collector cannot access this stack, but here garbage collector can access the reference variable objects. And we have seen this garbage collector in detail in the previous session. Please watch my previous sessions to know about garbage collector. And how garbage collector work is, if there are any unused memory objects, so that garbage collector will come into picture and freeze that memory so that your performance will be increased drastically. And reference types examples are string, object, class, and interfaces. Do not worry about these words, class and interface. In the coming classes, in the coming sessions, definitely we'll discuss in great detail about class and interfaces. As of now, just remember that reference types are used by reference which holds address to the object but not the object itself. Garbage collector can access these reference variable objects. Remember these things, and examples are string, object, class, and interfaces. Now let us see that what are the stack and heap. We know that value types variables can store directly in stack. Reference will be holding in a heap memory. Stack is used for static memory allocation and heap for dynamic memory allocation. Both are stored in the computer's RAM. Stack is used for static memory allocation, whereas heap is for dynamic memory allocation. So variables allocated on the stack are stored directly to the memory. So whatever the variable it is declared, that will be stored directly to the memory and access to this memory very fast. And its allocation is dealt with when the program is compiled. So compared to the stack and heap, stack is fast. Stack variable accessing is fast. That means compared to heap, because it's saving that values directly in the stack, and its allocation is dealt with when the program is compiled. When a function or a method calls another function, which in turn calls another function, etc. The execution of all these functions remains suspended until the very last function returns its value. The stack is always reserved in a LIFO order. Stack is always reserved in a LIFO. People who don't know about LIFO, let me tell that. Last in, first out. Suppose you have a tray. In a tray, you are keeping some discs. The first disk you kept, and the second disk you kept, and the last disk you kept. While removing it, last disk you need to remove first. Then the first disk you have kept will be coming out at the last. Otherwise, you can take other examples. You are keeping some blocks in a otherwise let me tell you that with the pictorial representation will be good. Suppose you have a disk like this, and this like this. You have kept disk like this, and this is the first disk you kept. Remember that. Number 1, number 2, number 3. It is number 4. All these things you have kept in a separate disk. So the first disk will be coming out is the last disk you kept, right? You wanted to get it out. The fourth disk will be coming out first. This is called LIFO, last in, first out. Stack is always reserved in a LIFO format. Variables allocated and the heap have their memory allocated at runtime. So stack, remember that, compile time. Stack means compile time. Just remember these words. When you are facing interview, please tell these things. Definitely interviewer will feel happy and will get a good impression. Runtime. So variables allocated on the heap have their memory allocated at runtime, and accessing this memory is a bit slower. So only I told that stack is fast compared to heap. But the heap size is only limited by the size of the virtual memory. You can use the stack if you know exactly how much data you need to allocate. So when do you use what? We can use stack if you know exactly how much data you need to allocate before compile time and it is not too big. If you can use heap if you don't know exactly how much data you will need at runtime, or if you need it allocate a lot of data. Remember these 2 points. We can use stack if you know exactly how much data you need, and you can use heap you don't know exactly how much data required at runtime. Hope it is clear. We discussed here value types and reference types, stack memory and heap memory. Thank you for watching this session. We'll meet it again for next session.